This is Calculus 12, and we're going to look at how to enter the RAM, rectangular approximation method, for a function and for a list. You need these two programs for Chapter 5.1. So let's bring up the TI. I press Program. We need a new program. We're calling it RAM. So R is the times, A is math, M is divide. Okay, and we have to enter these lines. And you can just follow along on this table. So we need input n parts. We're on line 1. So program, write 1 second alpha, that's to alpha lock, plus quotes log 0.8 math times 4 ln 0 plus alpha to get it out of alpha lock, comma alpha log, and enter. That's how we do the first line. Now we do the second line, program, write 1 alpha lock, quotes L E F T space left end space quotes, get it out of alpha lock, comma alpha math, that's A. And now we're going to do the right end. Or in this line now, program write 1 alpha lock, quotes R I G H T space end E N D space quote, get out of alpha lock, comma, and alpha B. Now we're on line 4. We want to do this calculation to calculate the width. And don't need this chart here. This is just bracket alpha B minus alpha A, bracket divided by N, alpha N. And we're storing it. This is the store key into W, alpha W. Enter. Okay, so line 5, we need to call some functions. So we'll jump over to here. On line 5, second stat. Right, we're doing a math operation. And we're doing the sum, that's 5. Alpha minus times second stat. We're going over to ops. And we're picking 5 per sequence. And the rest is easier just going by this. So we want y1, so this is vars, y vars, function y1, comma, x, comma, alpha a, comma, alpha b, minus alpha w, comma, w, alpha w, bracket, bracket, store into alpha t. Okay, now we're going to do display RAM. This is just program IO displays number 3. And we're going to do alpha lock, quotes, LRAM. L-R-A-M. And we're going to do a space and a quote, get it out of alpha lock, comma, alpha T. And we're storing these values into memory so that you can use them for other calculations if you need to. And we're going to do the same thing as this one. So it's hard to remember. So we'll go back to here, second, stat. We're scrolling over twice for math, number 5 for sum. And then we're doing alpha W times, now we're doing second stat again, and we're going over once, and number 5 for sequence. And again, I'm going to do the rest just by looking at here. Vars, right for y vars, function, enter, y1, comma x, comma alpha a plus alpha w divided by 2, comma alpha b minus alpha w divided by 2, comma alpha w, bracket, bracket, store into alpha u. And we're going to display MRAM. So program write 3 alpha lock quotes M RAM space quote out of alpha lock, comma alpha u. And then we're going to do another summation. So second stat, right, number 5 for sum, alpha w times second stat, right, 5 for sequence, y1, so vars, y vars, function, y1, comma, x, comma, alpha a plus alpha w, comma, alpha b, comma, alpha w, bracket, bracket, store, alpha v. And you get faster with this the more you do it. And then program IO, that's right, 3 to display, alpha lock, quote, RAM, space, quote, comma, alpha V. Oops. I need to get out of alpha lock, comma, alpha V. Okay, always take a quick look to make sure you're entering what you're supposed to. And we're going to wrap this up by testing it. And we're going to test it on a simple function. Clear 0.25 x squared plus 2. And then we quit. And then we press program. And I go down to 3 to execute RAM. And I press enter again. We're just doing one partition, 0 and 4. And I get the same numbers. So we have a good program that we've typed in. So let's just try it with one more function just to make sure. Clear, x squared, that's a simple function. Quit, program, select RAM. We'll do 4 partitions this time, 0 and 4. And we got 14, 21, and 30. And that matches this one. So our program's functioning properly. Let's enter the second program. It's not quite as long. It's the RAM list program. So if you don't have a function and you just have a table, you need a different program to do this. Okay, so line 0, program, write. We're doing a new program, R, A, M, L, and enter. Now we're entering line 1, program, write, 1. We're doing input. We're putting in an alpha lock, plus, minus, 0, plus, getting it out of alpha lock, alpha W, so we're entering alpha W, or W. Okay, now we're going to call the stat function, write 3, second stat. We're just doing the dimension of list 1. And we're doing a bracket, and we're going to store this into alpha log, which is n, and enter. Okay, so we're storing the dimension of n. We don't want to enter the number of elements. We just want it to calculate the number of elements. And now we're going to just sum up all those elements. Second stat, ops, sum is not in this one. It's actually in, so I'm missing another right symbol here. So you should have another right symbol. And 5, and we're going second stat, L1, so we just press enter, bracket, and we're going to store this into alpha lon. So that's our sum. Now we're going to display. Okay, so program, write, all our IO functions, display is 3. I'm going to put in alpha lock, LRAM, LRAM. Okay, so I missed the character here. If you miss a character, second del, that will insert a character, and I want to insert a bracket, or a quote, sorry. And then I want a space, that's 0. And I want a quote, and I'm going to get out alpha lock, comma, bracket, alpha S, minus L1. So we want to take off the first element to get a left approximation. So list, and we're getting rid of the last element, which would be n, alpha n. And then we're going to multiply the whole thing by w, the width, alpha w. Okay, now we're going to display MRAM, program, display, alpha lock, quote, MRAM, space, quote, get it out of alpha lock, comma, bracket. We're going to do 2 times the sum of the list, alpha S, minus the first element and the last element. So second list, bracket 1, and subtract the last element, second list, bracket n, alpha n, and bracket, and then multiply by the width divided by 2. Alpha w divided by 2. That gives us the average. And finally, display alpha lock, RRAM, quote, get it out of alpha lock, comma, bracket, sum of the list, minus the first element. Multiplied by the width. And we're ready to test this program. And here's our sample data. We don't need to enter these because we know the partition width. So to enter the list, we press Stat, Edit, and we enter our first list. So 0, 44, and you just keep entering numbers. So I have 13 elements, and I'm not entering the 14th element. So I have the right number of elements, and you can always scroll back to check to see if your table is correct. If you feel it's correct, just press second quit. We're going to do program. We're going to run Raml and enter, and we're going to enter our width as 10, and it generates the correct values. It matches, so we know it's functioning. So now you have your RAM and RAM list programs. And that completes this lesson.